طيب تمام، نبدأ على بركة الله. بسم الله الرحمن الرحيم. بادئ ذي بدء، أتقدم بالشكر الجزيل لنادي الطلبة المطورين للشرق الأوسط وشمال إفريقيا لمدى إسهامهم في الحرص على تبسيط التكنولوجيا لكافة شباب المنطقة على وجه العموم، وكذا تيسير العملية التعليمية التعلمية لكافة أطياف المجتمعات، وأخص بالذكر آية السيد وسليم العبيد. لا أريد أن أخوض في ذكر الأسماء حتى لا أنسى أحدا، لكن لكم منا جزيل الشكر. إذا سيكون معكم طوال هذه الحصة في هذا البث المباشر أخوكم إلياس بنتاشفين، طالب دكتوراه بتخصص معلوميات وقائد نادي الطلبة المطورين بجامعة السلطان مولاي سليمان كلية علوم طلبة كلية علوم تقنية المناظرات. كذلك سيرافقني طوال هذا البث المباشر أخي الفاضل أنس عبد الحميد العلامي، وهو أيضا زميلي في سلك الدكتوراه، وأيضا هو co-leaders of DEC Developer Students Club بني ملل. ستكون هذه الحصة كما هو مبرمج باللغتين الإنجليزية والعربية، حيث سيكون العرض بالإنجليزية والشرح والإجابة على الأسئلة بالعربية والإنجليزية. فمن كان لديه أي سؤال لا ضير أن يطرحه حتى يكون هذا طرح تفاعليا. إذن على بركة الله نبدأ على المنوال الآتي. إذن نحن في إطار Digital Days for Middle East and North Africa في هذه الأسابيع التعليمية. طوال هذه الحصة سنتتبع البرنامج الآتي. سنبدأ بintroduction and RPL routing protocol for low power and lossy network. ثم سنتحدث عن objective functions of this RPL, limitations of RPL, and conclusion and discussion. كما هو مبين في العنوان routing protocol for low power and lossy networks RPL for short. لكن لا يمكن أن نتحدث عن ال RPL قبل أن نطرح مجال تطبيقها وحاجتنا إلى هذه ال RPL. إذن introduction. Then سيكون العرض باللغة الإنجليزية، والشرح والتفاعل مع الأسئلة سيكون باللغة العربية والإنجليزية أيضا، ما في مشكلة. اللي عنده أي سؤال يطرحه كما يريد. Even electronics have enabled the development of low-cost, low-power, multifunctional sensor nodes that are small in size and communicate wirelessly in short distances. These tiny and generally simple sensor nodes consist of sensing units, data processing, and communicating components. A large number of such nodes deployed over large areas can collaborate with each other. To be cost-effective, the sensor nodes often operate on very restricted energy reserves. Premature energy depletion can severely limit the network service and needs to be addressed considering Internet of Things application requirements for cost, deployment, maintenance, and service availability. Open nature deployment and communication protocol show that WSN or wireless sensor networks optimization for reliable operation is time-consuming and costly. It hardly satisfies the Internet of Things applications requirement for long-term, low-cost, and reliable service unless reusable hardware and software platforms are available, including flexible internet-enabled servers to collect and process the feed data for Internet of Things applications. Then, the main question now is, what is wireless sensor networks? WSN for short. WSN is bidirectional wirelessly connected network of sensors in multiple hop fashion built from several nodes scattered in a sensor field, each connected to or can collect the object-specific data such as temperature, humidity, speed, etc., and then pass on to the processing equipment. The sensing nodes communicate in multiple hubs. Each sensor is a transceiver having an antenna, a microcontroller, and interfacing circuit for the sensors as a communication, actuation, and sensing units respectively, along with a source of power which could be both battery or any energy harvesting technology. However, has proposed an additional unit for saving the data named as memory unit, which could also be a part of the sensing node. A typical sensing node is shown in the figure below. As you can see, there is antenna and the transceiver, the processing unit when we have the memory unit, and from where we can collect the data using the sensors. There is a lot of area of applications of this WSN. Of their utility exists in smart gardening, like for gardening, sensors will be able to measure the light, humidity, temperature, and other gardening vitals. Then there is some kind of smart home, which IoT will also provide solutions for home automation with which we will be able to remotely control our appliance as for example, there is their application in the smart transportation. As you know, the development of smart transportations is generally led by government or transportation authorities. Successful examples include real-time traffic and public transportation information sharing, intelligent traffic control systems, incentive program to regulate transportation, largely promotion of electric vehicle and charging facilities, and dedicated short-range communication enabled vehicle or communication system. For example, there is navigation and safety, and then road planning and road optimization. There is another area of application, smart hospitals, and let us talk about the main subjects of this session is RPL. What is RPL? Routing protocol for low power and lossy networks is a distance vector routing protocol. Here, the routing is based on destination-oriented acyclic graphs or DODAGs for short. طيب ما في أسئلة لحد الآن؟ إذا نتابع. قلنا كتعريف ال RPL routing protocol for low power and lossy networks is a distance vector routing protocol. The routing is based on destination oriented acyclic graphs or DODAG. Then first of all, we should explain before understanding RPL and how this terminology and key concepts which are at the heart of this routing protocol. First of all, we have directed acyclic graph. Is a graph that contains no cycle. We see such kind of graphs in spanning trees. For example, كما تشاهدون على الفيجر، مثلا إذا أردنا انطلاق من نقطة واحد إلى نقطة ثم نعود إليها لا نستطيع. إذن there is no loop بطريقة أفصح، يعني مش ممكن أن أنتقل من نقطة ثم أعود إلى نفس النقطة في خلال نفس الجراف. وبالتالي directed acyclic graph يعني الاسهم تذهب في اتجاه واحد، يعني من النود 1 ثم النود 4 الى النود 5 الى النود 3. ثاني شيء نتحدث عن is route. It is the destination of the nodes in directed acyclic graph. It has no outgoing edge كما شاهدنا في الفيجر الأولى. كما تعلمون route هو الرقم 8 حيث أنه لا يخرج منه أي سهم من الأسهم، وبالتالي يكون هو الأب لجميع الأبناء الذين يأتون من بعده ويسمى الروت. ثم up. It's any edge that is directed toward the root. يعني كل سهم يوصلنا إلى الروت هذا هو نقصد به up. Down, it's any edge which is directed away from the root. كل سهم قادم من الروت هو نسميه ب down. الآن destination oriented directed acyclic graph. This is a special kind of directed acyclic graph. Single destination. جميع الأبناء، جميع النودز، جميع العقد الموجودة هنا، جميع الوحدات تريد لديها destination واحدة single destination وهي أن تبلغ الروت. طيب هنالك مفهوم rank. It is the distance from the root. لاحظ معي هنا هات أقل رانك هو النود A، ثم الرانك نمبر 2 يعني الصف الثاني هو نود E B and F، ثم الرانك الثالث وهو الصف الثالث يعني هم أقرب مسافة إلى الروت. تقاس المسافة بالأقرب فالأقرب، كل ما كان قريب مثلا عفوا CDG هو الرانك رقم 1 يعني الصف رقم 1، EBF صف رقم 2، ثم A صف رقم 3 وهكذا. إذن لدينا أيضا مفهوم RPL instance. When we have one or more dodags, then each dodag is an instance shows to the RPL instances. هذا ال RPL هو بروتوكول سيساعدنا على نقل مجموعة messages بين النودز داخل هذه topology. Then there is five types of messages exchanged on the RPL topology. The dodag information object, or DIO for short, this message is multicast downwards. A given node in a dodag may multicast this message. About it. Things like whether the node is grounded or not, whether it's storing or non-storing, and it announces other nodes. If they are interested to join, please let me know. The second type of message, there is information solicitation, DIS, when no announcement is heard. And if a node wants to join a dodag, it sends a control message for that it wants to know if any dodag exists. So the message which it sends is like, is there any dodag? The third one is dodag advertisement object. It is a request sent by a child to a parent or a root. This message request أراد أن يدخل إلى توبولوجي يرسل مثل هذه الرسالة. ثم لدينا DAO acknowledgement. It is a response sent by the root or parent to the child if the response can either be yes or no. في حالة ما الروت قبل بانضمام هذا العضو الجديد أو لا. ثم عندنا consistency check deals with security. And we need not to know much about it now. Then, this is the scenario that can RPL control messages, how it exchanged. Then now I will let you with my friend Anas.
Hello, everyone. I hope you're doing well, and I hope you're following along. So, the objective function. So for to do this, we're going first to define what is an objective function. Well, simple as it is, it's something that allows nodes to translate one or more metrics and constraints into a value called rank. This rank is actually what Ilyas has just explained. It is like the distance of a node from the sink or the dodag root. Also, the objective function defines how node selects parents. Obviously, it's a routing protocol, so we need to select our parents. So the objective function defines how we do this, and how does the objective function knows which parent to select. In this case, the objective function use the information that are carried that Ilyas has just explained to you. So the objective function make use of something which is called metrics and constraints, which is something that really help us to define to know which metric to use or which constraints to use in order to select the parents. Very fast, a routing metric, it's a quantitative value that is used to evaluate the path cost. The path cost is very important. Is as simple as it is. It is like how much it's going to cost us to go, like for instance, from the root to a node. So a routing constraint, it is something that we use as a filter to prune links and nodes that do not satisfy the specific properties. So, for example, we may define an objective function that will require for a path not to cross a node, not to traverse a node that are battery powered. This is an example of objective. We have two types. We have link metrics and we have node metrics. And the link metrics, they actually deal with the quality of the link. And we have three major link metrics, which are the RSSI and the link quality indicator. And we also use the ETX, which stands for the expected transmission count, that which indicate the network reliability. And it presents the number of the transmission needed to receive an acknowledgement from the destination. Also, as far as the node metrics concerned, we have the energy. It's very important, like when designing an objective function, to pay attention to the energy, because we are dealing with networks that are low in power. So we should put this in our we should take this into our consideration when designing an objective function. Also, we have the hop count, which is like one of the most used routing metric in the path length in a network. The main drawback of this metric is sometimes it may choose a low path that provides us with our low hop count, but the link, but we may have some problem with the link quality. Also, we have end-to-end delay. It presents the time required to transmit a packet from sender to node to the node, from sender nodes to sink. This is very important when designing a real-time application, for instance, like transmitting video or audio. And the RPL comes with two default objective function. The objective function 0. It uses one metric. It only uses one metric, which is the hop count. As we just mentioned, the hop count may sometimes the objective function may use node that has a minimum count, hop count, but also like the link is unreliable. So this is one of the drawbacks of the objective function 0. And to remedy to this, they come up with something new, with another objective function, which is the minimum rank with hysteresis objective function, which is designed to find the path with the smallest path cost while preventing excessive churn in the network. It does so by using two mechanisms. First, it finds the minimum cost path. For example, the path should have a minimum rank, and the second, it switches to that minimum rank path only if if it is shorter than the current path by at least a given threshold. Like for instance, we have, as we mentioned, like we do some consistency check the network topology might change. So we need to put in our consideration the link of the new in this objective function. So one of the good things about the RPL is like they separated the objective function from the core protocol specification, which allows RPL to be adapted to meet the different optimization criteria required by a wide range of deployment and application and network designs. So I'm going to give you an example of an objective function that uses the minimum rank with hysteresis object with hysteresis. Like for instance, we can use latency as a link metric. For instance, to allow RPL only to choose the path that give us like the minimal latency, for instance. As far as the limitation concerned, as you know, we're talking about low lossy networks. So we have the problem of memory. We have small memory. And also we have the power, which is very limited. Time to dive deeper into the limitations. We're gonna move on to the conclusion. So for the conclusion, the interface is considered as a revolutionary technology that allows connection every object to the internet. It covers a set of domains such as healthcare, military, industry monitoring, building a smart home in the purpose to make our daily life easier and more secure. The tiny devices used in the IoT are lossy, low-powered, and have limited resources. Hence, the use of an optimal routing protocol in such context becomes a necessity and a challenging issue for many researchers. A working group that goes with the name IETF role has proposed an IPv6 protocol for low power and low networks, which is called RPL. That has several advantages for tiny devices. One of its main strengths relies on the flexibility to handle and manage network topology changes and implementation modification. Moreover, it is also used to respond to the low lossy network requirements, such as the load balancing, imbalanced energy consumption, and network traffics.
إذا شكرا جزيلا. انتهت هذا العرض إلى حد الساعة. فاضل معنا تقريبا دقيقة فقط. إذا كان هنالك سؤال فلتتفضلوا مشكورين. أتمنى أن نكون قد كنا واضحين في السيشن. إذن ربما لم يتبقى الكثير من الوقت. على تتبعكم. إن شاء الله لا زالت لدينا حصص قادمة حيث يمكننا أن نتواصل أكثر فأكثر، وسنتحدث في القادم عن كيفية الدخول إلى برنامج DAC والانضمام إلى جوجل ديفلوبر. شكرا جزيلا. كان معكم إلياس بنتاشفين وأنس عبد الحميد العالمي. صراحة لا أحب الكلام كثيرا عن هذا المجال، لكن صراحة عن طريق DAC نستفدت الكثير من الأمور، من بينها أني التقيت ناس لما سافرت لدبي على نفقة DAC جوجل ديفلوبر، كانوا في حسن استقبال، وفروا لنا جميع المسائل. وهذا نتيجة ماذا؟ نتيجة أنهم وفروا لنا هذه الوسائل مثلا كويك لابس وغيرها، حتى نقوم بتبسيط تكنولوجيا في جامعة السلطان مولاي سليمان ببني ملال، حيث قمنا بجملة من الورشات التي كان من شأنها رفع مستوى الطلاب، كانت تنافسية كثيرة، تعرفنا على مفاهيم جديدة، تعرفنا على ناس جدد متخصصين في التقنية، وكذلك نحن على حين submission of solution challenge إن شاء الله نكون الفائزين. إذا شكرا لكم حتى لا نطيل على حضراتكم، والسلام عليكم ورحمة الله. إلى لقاء آخر، مع السلامة.